Hello, I'm Dalton. I'm presenting our paper entitled Trusted and Untrusted. That is the access. Improving access control allowing only trusted execution environment applications. And our introductions is regarding security concerns that we have when processing, transmitting, and storing sensitive data. For instance, we can have personally identifiable information or protect the health information that should be protected when processing because can have security issues or privacy issues. Another possibility is an attack known by non-intrusive appliance load monitoring. How this attack works. If an attacker gets access to an energy consumption data, he or she can infer the behavior of users inside a residence, for instance, inside a house. If this attacker gets access to an energy consumption database, he or she can infer what a specific user was doing at a specific time, for instance, taking a shower or watching TV. So this is a privacy issue. To mitigate these kind of problems, this security concerns, security and privacy concerns, we can apply generic security mechanisms such as cryptography. We can apply cryptography to data in rest or to protect data in rest or data in transit. We can apply access control mechanisms such as policy enforcement point proxies. These proxies intercept the requests and verifies that if the requesters have permissions to access data and service providers. And we can also apply trusted execution environments. This kind of environment enables the creation of isolated and protected regions of memory by using processor extension. And this kind of protected region is commonly called enclaves and also trusted application, trusted word. So if we have a trusted execution environment, we can have these enclaves or trusted words that are protected, even if an attacker gets privileged access. So the most common trusted execution environments available in the market are ARM Trust Zone and Intel SGX. And it's valid to mention that trusted execution environments are the basis for the confidential computing. So confidential computing is related to protect data during processing. The trusted execution environment should have an attestation mechanism that allows third parties to attest that an application really runs inside a trusted execution environment. So if we have a trusted execution environment running an application, these trusted execution environment should provide a means to attest for third parties, attesting that it really runs inside a trusted execution environment. Given these security concerns and mechanisms, we define some research questions for this work. But two research questions, which are how to improve security by decreasing the distrust in the data consumers requesters, how to improve the trust in consumers that will process our sensitive data, and how to improve access control in a way that only trusted parties can access sensitive data. By trusted parties, we are referring to the parties that runs inside a trusted execution environment. So we are requiring that our consumers, our data requesters, will run inside trusted execution environments. That means that we will have confidential computing, or data during processing will be protected. The main contribution of this work is listed here: improve the trust in data consumers requesters by allowing sensitive data distribution only to trusted entities. Our proposal considers an improvement to a policy enforcement point proxy that I will show you later. We are calling this improvement TRUP, and which means Trusted Policy Enforcement Point Proxy. And to validate our idea, our proposal, we developed a colored pattern model, a CPN model, to verify some desired behaviors of our proposal. This is a common functionality of the policy enforcement point proxy. We have here a policy enforcement point proxy, a common one, and we have a requester, we have a protected source, and the right side a protected source, the left side a requester, our consumer. And we have here below an identity and access management system, IAM, or identity management system, IDM, or even a PDP, policy decision point. Each of these can be used to validate and verify if the requester has permission to access protected service. So a common flow, a common communication flow can be a requester requesting some data, sensitive data, which are stored in the protected service. The policy enforcement point proxy intercepts the request, verifies if the requester has permissions to access the protected data, and in a successful case, if the requester has permissions, the policy enforcement point proxy forwards the request to the protected service, and the protected service will answer the request with the sensitive data. To our proposal, we defined this application scenario, which consider producers generating data for the case in which we have neon attacks. As I mentioned before, we can have these producers being smart meters. So the smart meters would be generating energy consumption data, stored in a data storage provider, and consumers will process this sensitive data. These consumers can be, for instance, energy supply companies. So we have to protect these data to avoid privacy issues, as I said before. The threat model considered for this scenario considers these attack surface, data in transit among the components, for instance, data sent from the producers to the service provider, and data sent from the service provider to the consumers. So we have to protect data in transit among these components. We have to protect data in rest inside the data storage provider. And we can also protect data in processing, during processing, which is the confidential computing. We have to care about the processing of data inside the consumers. Some design principles to our proposal. We apply cryptography. We require that cryptography mechanisms should be applied to data for protection during rest inside the storage provider or during communications between the components, as I said. We employ security channel, a security channel to communications between the entities, for instance, between the producers and the service provider, and between the service provider and the between the producers and service provider, and the service providers and the consumers. And also, we require that a trust execution environment should be employed, must be employed to protect data during process inside the consumers. So a policy enforcement proxy must execute the attestation process to verify if the consumer that is requesting sensitive data really runs inside a trust execution environment. This means that the consumer will receive the sensitive data only if it runs inside a trust execution environment. So the policy enforcement point proxy will perform the attestation process beside authorization. The authorization process only verifies if the consumer, the requester, has permissions to access data. So besides checking the authorization, if the request has permission, the policy enforcement point proxy will also verify if it really runs inside that trust execution environment. The consumer receives data only when the attestation process is successful. This means that it really runs a trusted application inside a TEE. It is the component we have here, access requester. Remember that I said that the isolated and protected region is called enclave. So the consumer has an enclave. It runs inside a trusted execution environment. We have a trusted PEP proxy here, the TRUP, and we have the protected session here on the right side. Here we have the identity management system. So the communication flow starts by the service requesting authorization token. The service request sends the credentials to the identity management system. The identity management system checks the credentials. Once they are validated, the IDM system sends back an auth true token. That is a token for checking authorization. With this token, the service request requests the sensitive data in the protected service. This request is intercepted by the trusted PEP proxy. The trusted PEP proxy, which is the TRUP. The TRUP verifies if the token is valid with the IDM system. Once this token is valid, it means that the service request has permission to access the sensitive data. Okay, so once the service request has permissions to access sensitive data, the TRUP starts the attestation process. Is this number 5 errors here? Is it starts the attestation process. Once the attestation process is concluded, if it's successful, it means that service request really runs inside a trust execution environment. So it will be capable of protecting our data during processing. So the request is forwarded to the protected service. The protected service responds with the sensitive data, which will be processed inside the enclave here in the service request. This is our improvement to the policy enforcement proxy. It is the message sequence diagram that I described now. For we have trusted service request, the IDM system, trusted PIP proxy, the TRUP, and the protected service. First, the trusted service request question authenticating the IDM system receives a token, generates the request to the sensitive data for the protected service, sending the token received from the IDM system. The TRUP verifies the token, the validity of the token with the IDM system. Once this token is validated, the TRUP starts the remote attestation process. After the successfully completed attestation, we have the forwarding of the request to the protected service. The protected service returns the sensitive data to be processed inside the enclave in the trusted service requester. Here is the model that we developed, the CPN model, correlated pattern net model. We have entities here, and we have the main communication flow. We have, for instance, the IDM system here, represented here. The entity sends the credentials to the IDM system, receives a token that will be sent to the trusted policy enforcement proxy, the TRUP. The TRUP will verify with the IDM system if the token is valid. Once it is valid, the TRUP will start the attestation process. The attestation process, once it is successful, will return to the TRUP. The TRUP will then forward the request to the protected service, and the protected service sends back the sensitive data to be processed inside the trusted consumer. To verify some desired behaviors of our proposal, we used a tool from the CPN tools that is a tool that we use to model our proposal. We verified some some behaviors using the state space analysis. For this, we implemented some CPN-ML functions. We have two here, just to exemplify. And the model presented the desired behaviors as we expected. That is allowing access to data only for consumers with trusted execution environments. These functions on the left side verifies if a consumer that doesn't run inside a trusted execution environment would have its request denied. So this function proved that once the consumer doesn't have a trusted execution environment, it will not process, receives, and process our data, our sensitive data. And the right side, the function on the right side, test verifies if a consumer containing running inside a trusted execution environment will receive the sensitive data and securely process our information. Concluding our work, we have a proposal that is an improvement to policy enforcement point proxies. This improvement considers that the policy enforcement point proxy requires that requests will run inside the trusted execution environment. To check this, the policy enforcement point proxy will perform the attestation mechanism, and once this attestation mechanism is successful, it will request the request to the process provided, allowing the receive to receive sensitive data in process. To validate our proposal, we implemented a CPN model, and we performed some verification of desired behaviors. For future work, we are suggesting the implementation of a policy enforcement point proxy inside a trusted execution environment application. The addition of a timestamp for a tested request. This will allow that once a consumer is attested, we don't need to perform the attestation process during some period of time. So once the consumer is already attested, it can request more sensitive data during a specific time. We also suggest the model check to perform model check of some security properties, and we are planning to experiment to perform some experimentation to measure CPU and time overheads of our proposal. Thank you very much. If any one of you have some questions, please can reach me. You can reach me at these emails. Thank you very much.